gas tungsten arc welding electrode classification. This is the electrodes you use for TIG, tungsten inert gas. There are a lot of different types of tungstens out there. They'll range anything from maybe 0.010 thousandths of an inch in diameter, and they'll actually go up to a 1/4 inch thick, which is almost a novelty to have one of those rather than practical. In most cases, you're probably using something between a 16th, 332, or 1/8 inch diameter tungsten in most TIG welding applications, at least manual. To begin, we have EWXX-X. Okay, so E, again, electrode. Now W is the periodic table of elements. W is for tungsten, and that comes from the word wolfram. Okay, alloying elements is what comes after that. So that could be a La for lanthanum, Th for thorium, Ce for ceriated, Zr for zirconiated, P for pure, or you might run into what is pretty popular now, and that's the mix, usually a tri-blend, LaYZr, which is lanthanum, yttrium, and zirconium mixed together. After the dash, you have the percent alloy. So, for example, if we had a thoriated rod, there are different options out there. Typically, you might run into a 1% or 2. Really, 2% is probably the most common. That is the red rod that was used for decades, and unfortunately, thorium is mildly radioactive, so a lot of the manufacturers have decided to stop making these. They still are available out there, and a lot of the old timers say that that's the best, and they still use it. There's a company called Wolfram. They actually make a 4% thoriated rod that's supposed to be pretty darn good. But anyway, so that's TH dash whatever the percent is. We also have lanthanum or lanthanated, and that could be found in 1.5%, and 2%. The 1 is a black rod typically, 1.5 is gold, and blue is the 2%. 2% lanthanated rods are actually one of my favorites. It's an all-purpose rod, DC negative or AC, no problem. Okay, ceriated can be typically a 2%. That is orange in some cases, but we have also seen other manufacturers do that in gray and other colors. But that one is a 2% ceriated. That is a general purpose rod. You can run that on DC negative or AC. Zirconiated, that is the brown rod. It's usually 1% zirconiated, and that is great for AC. So if you're going to TIG weld on aluminum or magnesium, zirconiated is a great rod. Pure is the green rod that is going to be a thing of a past now. Very few people are using it. These ones that are alloyed with these oxides are much stronger. They'll actually last a heck of a lot longer without sharpening or really just the end of the electrode breaking down. You got to think of the amount of electrons hopping off the end of this electrode. The heat, it's intense. So over time you'll start to see your points splinter like this, and we don't want that. Or even just the ball at the end, which I shouldn't say ball, I should say it's rounded. That can't handle the heat, so it starts to actually turn into this, and we really don't want that because your electrons are then jumping off a little bit further than what it would here. Okay, that's your pure. It's green. It's good to know that it's green. I would avoid it. They're cheap, but I would still avoid it. And then that mix is lanthanated yttrium, zirconium, and those are different percentages. Not important to know. Just know that it's a tri-blend. And those are typically going to be a purple identification band at the end, or what they call chartreuse, which is kind of like a greenish yellow mix. I've seen them both ways, and I've seen pink ones from a manufacturer as well. Uh, Learning the colors can be a good thing, maybe not. Depends on who's making the actual tungsten these days. They don't all follow a standard color chart, unfortunately, to make it easy. Overall, there's a handful of different options for TIG electrodes. Try them all out and see what you think. I would encourage you to try the 2% seriated and the 2% lanthanated. Those are great rods, but obviously now with the tri-blend, the lanthanum, yttrium, zirconium, that's been working great as well. But the more you try this stuff out, the better you're going to understand why some people choose one over the other. And probably more important than anything is actually sharpening your tungsten when using on DC negative, and also controlling your positive negative on the AC to make sure you're not really welding with a giant ball at the end. If it is balling, maybe you need to step up the size of your electrode. So if you're using 332, maybe step it up to an 1/8 inch and help dissipate some of that heat. That is Gtaw electrode classification.